Hi and welcome to Azimotion. In today's episode, I'm going to clean up our project that previously created a bit. So, if you can remember, we have added the third person game template from Unreal Engine using this and feature or content pack. But I'm gonna remove some of the content today by aligning into Unreal Gameplay Framework and create our own gameplay framework classes. So before creating these classes, it is good if we can understand them better. So without the course of Unreal Game Engine development, they have created many games. For example, Fortnite is one of their games. So by creating those games, they have understand different genres of gameplays and game architectures. So based on that, they have abstracted a framework to give the users a much manageable set of classes to create their games. So understanding these classes will give more freedom to Unreal Engine users, so they all can align to this framework and get the maximum use of them. So in this framework, the first thing that we need to look into is the game instance class. So if you go into a project and edit project settings in maps and modes, you can see that there are these default maps, game modes and other settings. So in the bottom you can see the default game instance is set to this project, and default gameplay map, editor startup map, and different game modes. So these are the gameplay framework classes, and for even split screen kind of local multiplayer scenarios, they have provided their framework. But we are going to look into these other classes which we will use in our game. So to access this game instance or to have more functionalities in these game instance, we will have to have our own classes without using these default classes. For example, in this third person template, they have used separate their own third person game mode class. So in there they have defined their what is their default player controller and what is their default pawn class. So they have assigned their third person character via this third person game mode. So what I'm going to do is create our own set of classes. So if you look at this game instance, in the documentation they have defined it as it is the high level manager for an instance of the running game. So that means when we run our game as an executable, it will create a game instance, and for each game that we run there will be only one game instance. For example, if we run this using this PIE mode, here we have like several modes. If we run this PIE mode, we can define how many players we can add. If we increase this, it will run 2 PIE modes. So then it will run 2 instances of the game, which means each of these will have a game instance class instantiated for each of these players or game instance. The wonderful thing about the game instance class is it will be there for the whole lifetime of the instantiated game. So, for example, level transition kind of things or gameplay settings, we can store those kind of data inside the game instance class. So there's a pretty good documentation or article that have created by Tom Looman. In there, he have explained more about this game instance class. So you can get more understanding by reading this document as well. So yeah, that is about game instance. If we explain it more, so the game instance is the place where we load different maps. Can load actually different maps. So in each of these maps, there will be a game mode. One. So the game instance can run one map at each time or one world at each time, and these worlds or these levels will have a game mode. The beauty of having a game instance is like we can switch these levels during the gameplay, and this can store like things like stats, game settings, and you can even load and play replays. So there are many more other features. When we develop our game, we will understand more about the actual usage of game instance. And game mode is the place where we will define our rules, game mode rules. For example, we can have a level with one type of game mode called, let's say we have a one level, one map. There's let's say forest map. It can have several game modes. Let's say it has a battle royale mode, capture the flag mode. So it can have these different game modes, but during the gameplay it can only have one of these at a one time. So we can have several game mode, but at any point it can have only one game mode, such as battle royale or capture the flag kind of a game mode. So during the runtime they can switch whatever the game mode they prefer for each of any of these levels. So game mode is basically the place where we define game rules, such as the things that I have mentioned earlier. So this is where actually we define the rules. So the player controllers can join to the game mode. The player controllers are kind of usually I remember it as a ghost, because player controller actually doesn't have any visualization in the map, but it can possess any pawn in the map or in the game mode. Game mode will load the player controller, and then player controller will possess the pawns that we need. These pawn can be a character or a vehicle, whatever playable entity. In the map could be a pawn. So player controller can possess this pawn. So the beauty about player controller is that is the only place that we can give input. If it is if this pawn is controlled by an actual player, he will get inputs via this player controller. Otherwise, it will controlled by a AI controller. So these both classes are there to facilitate these different functionalities. For example, NPCs will be simulated using this AI controller. So for this AI controller, there will be different behaviors defined. So using behavior trees. And so then this pawn or character or vehicle will be controlled either by a player controller and AI controller. So any player only can have a one player controller, or there will be only one player controller on one local machine. But for split screen kind of scenarios, there will be two local controllers. That's a different scenario. So, and this player controller can get input, and there will be a camera manager for this player controller. So he will access this pawn's camera and control it. Yeah, I think now you have a basic understanding about the gameplay framework. Now we can go into our project and set up our gameplay framework classes that are required for now, and link them in order to work in our game. So I'm going to go into a sim folder. Inside there, I'm going to create a new folder to hold our game framework classes. I'm going to call this blueprints, and here I'm going to create a blueprint class. So the first class that I'm going to create is the game instance, of course. I'm going to create game instance. I'm going to name it as BP AC to annotate Azimotion, AZ game instance. Alright. Now we have our own game instance. So to actually to work this, we will have to add this our own game instance class to the project settings. So you can go to map and modes go to game instance class and set up the game instance. All right. Now we can create a new class called game mod. So I'm going to create game mod class. So I'm gonna name it as BPSC game mod. Compile and save it. It comes with these default game mods, game mode link classes. So the next class that I'm going to create is the player controller class. Yeah, it's BP BPAC player control. You can see these logos like define actually what these classes are. So if we go here and press Ctrl Alt, you can see what these classes are doing. Game mode. For example, the game mode base defines the game being played, governs the game rules, scoring, what actors are allowed to exist on the game type, and who may enter the game. So there are these details, you can always refer them. Let's create the last class, which is a character. So I'm going to name this BPAC base character. Alright, now we have created the main 4 classes. So the next thing I'm going to do is I'm going to link our player controller as well as our default pawn class to our game mode. So after that, we can add our game mode to this level. So now when you hit play, our game mode will be applied. If you can remember previously, I'm gonna reduce that to 1. If you load third person game into this level, you can see that there is the player we added in the previous episode. But if we set this to our newly created game mode, we can only see this guy and we don't have any control. Alright, the next thing that we are going to do is improve our character to have control and have a mesh. So let's open it and open full blueprint. If you can see, there's a mesh, but that is empty. So I'm gonna add the same mesh that we have added previously. So we might have to adjust this. Yeah. Yeah. So if we hit play now, still we can't see anything. That is because we don't have a camera. So I'm gonna add a camera boom. So I'm gonna add a spring arm. So I'll rename this camera boom spring arm, and I'm gonna use point control rotation and add a camera. I'm gonna name this follow camera. Alright, now we have a camera, and if we play now, we have the character, but if we press WSD, the character actually cannot move. So if we compare this with the third person character that we have right now, it has this camera boom and follow camera, and for mesh they have applied these third person animations. So the first thing I'm going to do is like add these similar functionalities, like for example the character can turn using mouse inputs as well as move using keyboard inputs, and jump. So let me copy these three, because I won't be using these touch controllers and gamepad controllers for now. And I'm gonna open my character. Alright. Let me copy. You may wonder how these input axis values are here. So if you go to edit, project settings, and input, you can see this jump, look up rate, move forward kind of actions are mapped to different keys. So for example, move forward is mapped to W, S, and move right is mapped to A and B. A gives negative values, B gives positive values. So we can move to two sides, and for forward and backward we can use W and S. So we can even add arrow keys to this as well. So we can use these actions or axis to give inputs or get inputs, and add these functionalities. So since I have copied this now, it has now our character have input axis turn, input axis lookup. That means when we move our mouse, it will turn and it will look up. and if we use our keyboards, the character will have the movement. Since this default character comes with this character movement component, we can directly use those two components, and our character can also jump. So no other code is added. Let's see what is happening. Okay, now our character can move, and yeah, and camera can rotate. All right, so but there's one thing missing, which is the animations. So since we have the same skeleton in our base character, we can use third person animation blueprint. So we can give here any animation asset for animation blueprint. I'm just gonna give third person animation blueprint and hit compile and save and play. Now this character have these animations. All right, now we can remove these characters and game modes we use from third person sample project, and these meshes as well. We are not using these meshes and this geometry as well. We can even remove these third person sample maps. The only thing that we are not going to remove is set of animations as well as a default mannequin character. Because we are going to use this mannequin throughout our project. One reason for that is then we can get use the maximum out of Unreal Marketplace, as well as a lot of content will create into this default Unreal mannequin. So by having this skeleton instead of custom skeleton, it is easier for us to integrate many features and packs. So I'm going to remove these three classes. Okay, delete. All right, now if we hit play, we have all the animations and the movements in our own custom character VPAC base character, and we have our own game mode and game instance and player control. All right, I think that is it for today's episode. So before concluding the episode, I'm gonna give you a quick reference regarding Unreal animations, because from the next episode we are going to create our own animation system and some melee attack system. So before going into the next episode, it is good if we can understand that as well. So in the character, we have assigned this third person animation blueprint. So each animation blueprint will have this kind of a event graph. So in this character we have used the default movement component, and using that we can get whether the character is on air or if he is falling or not. Then we can use that variable, and also we can get the character and get the speed of that character and use it to drive our animation graph. So in our animation graph we have a state machine. Apart from the state machine, we have the output pose, which is the output of our state machine. So in this state machine we have different states for idle, jump start, jump loop, jump in. So to go from this state to this, there's some transition logic. So in here you will check whether the character is in air or not to jump start. So by getting the input, the character component, the movement component of the character will, this is the default movement component. So it will take the input and define. So we have defined to use jump and stop jump using this character movement. So these functions are defined inside this character movement class as well. Yeah, movement class. So we can take that information process this animation blueprint like this. So anyway, we will be changing these logic later on, but it is better to understand how these animation blueprint and the event graph in the animation blueprint and animation graph. And inside animation graph we have output pose and state machines, and there are different states, and each of states will have different animations. Jump animation for this state and transition logic to each state, and for example some of the state may have different without putting directly an animation, we can put a blend space as well. So if you look at the blend space, it has some animations combined together. So we can provide the speed, the character speed we gave from the animation blueprint, and depending on the speed we can blend different animation. So this is a one-dimensional blend space, so we can use these other axes as well to derive more combinations of animation using drive by different variables. So we will be using those things in the upcoming episodes. So I think now you have a basic understanding about overall Unreal's gameplay framework and a little bit about animation blueprints. So give your thoughts about the project. As well, if you have any questions, put them in the comment section, then I can answer them. The links to this documents, I will provide them in the description. And then see you in the next video.